let's graph one. So we're going to graph y equals 2, and then x minus 4, and then x plus 1. Okay, this is the only, of the three, this is the only one I'm going to not ask 5 points, but instead I'm going to ask you to graph just 3 points, and I'll be happy with that. Those 3 points include the intercepts and the third point being the vertex. So with this, we don't start, well, I don't want to start with the vertex. I want to start with the intercepts. So first we're going to graph x-intercepts. Okay, so that means we need to know our P, and we need to know what our Q is. Remember, it's a minus P and a minus Q in the equation. Okay, in the general equation, it's supposed to be minus P and minus Q. So because in this first one it's just minus 4, then the sign didn't change. That means our P value is in fact going to be 4. And our Q value is, if we look here, oh wait, that's a plus 1, but it's originally minus Q. Well, how do you get a minus sign and make it plus? That means you put in a negative. Okay, that means that, you know, this is in fact a negative 1 where we had a subtraction sign originally in front of it, so that made it plus. So with that logic, we can say, oh, well, Q is in fact negative 1. Okay, so knowing that our coordinates are going to be 0, 4 and 0, negative 1, that's going to be our x-intercepts. So 0, negative 1 will put us right here, and 0, 4. 1, 2, 3, 4. Okay, next we're going to find the vertex. To do the vertex, we have to find the axis of symmetry first. Okay, so I guess we could say a subset. We need to, find axis of symmetry. Okay, so we could actually make that our second step. Find the axis of symmetry, and then we're going to find the vertex off that. So the axis of symmetry is right in the middle. It's between those 2 points. Now, these are 2 whole numbers. It's not necessarily always going to be 2 whole numbers, or integers, rather. And you want to use the formula. Well, it's the average of the 2. So it's x equals, remember it's a vertical line, P plus Q. So P plus Q divided by 2. So P, which is 4, plus negative 1 divided by 2. So 4 plus negative 1 is 3, and then divide that by 2, so it's going to be 3 halves, or 1.5 is going to be the equation of that. Okay, so we're going to have to find 1.5. Actually, let me find that on the x-axis. So that's going to be 1 and then halfway between right here. So let me kind of draw that in. So here's my axis of symmetry, halfway between 1 and 2. Now our vertex is on here somewhere. Now I know this vertex is going to be a minimum because the a value is 2. It's positive, so it's opening up. Thus the vertex is a minimum. And it's got to be somewhere on this axis of symmetry. Where? Well, we figure it out by taking that x value for the axis of symmetry, because they have the axis of symmetry and the vertex have the same x, and we substitute x into the equation and find y, and that's the other coordinate we need for other part of the coordinate we need in order to get our point. So let's do that. Let me give myself a little bit more room to work with. So I'm going to scroll down here. All right. So it's y equals 2 times 1.5 minus 4 times 1.5 plus 1. All right, so 2, and then this is going to give us negative 2.5. And this is going to give me positive 2.5. All right. And now we just multiply this whole mess together. Okay, so that's going to get me negative 12.5. Okay, so we will substitute, so my point is that my vertex is at 1.5, negative 12.5. Okay, so that's my graph isn't quite big enough for that. So that point's going to be actually beyond my graph. I'll just put it right here. Let me highlight that point. So that's my point right there. It's 1.5. I'm just doing that so you can negative 12.5. Okay, doing that so you can see it. All right, so now I'm going to connect my 3 points and get my parabola. So it should look like this. It's just going to kind of curve up. Oh, wow, that's really not good at all. And yeah, that's the opposite of good too. That's like anything but good. That is really hard for me to do on here. Okay, so anyway, hopefully you'll do a much better job than I can do with what I have. Let's get away from the graphing and let's take a look at something that's just more algebraic. So we're going to write an equation that's in, well, what form is this in? Hopefully you're thinking or saying or screaming out loud intercept form. And one of the things we want to be able to do is convert between the different forms. So converting between this form, intercept form, and the standard form is pretty easy. We're calling that standard form is y equals ax squared plus bx plus c. So all you have to do is just multiply this mess together. So y equals, so I'm going to distribute to 3x minus 12, and x plus 6. Now you have a binomial here, binomial meaning two monomials, 3x and minus 12, or 3x and 12 be the monomials, and then x and 6 are the monomials for the binomial on the right. So how do we do that? The way I want you to view it, kind of used to viewing it, is we take the first term and distribute it to both terms in the second binomial. So we have y equals 3x squared plus 18x. And then we take the negative 12 and then we distribute that to both terms. So negative 12x, and let's see, it's going to give me 72, negative 72. So now we just simplify. So you just distribute, think of it as distributing the first term to both terms and the second term to both terms on the second binomial. So 3x squared plus 6x minus 72. So now it's in that form of standard form, y equals ax squared plus bx plus c. Okay. You also will need to be able to convert from vertex form into standard form. So really it's, fairly similar. Just got a couple of extra steps here. Okay, so first off, I'm going to say, well, what we're saying here is we got y equals negative 2, and then here we have x plus 8. Okay, the squared here does not distribute. Exponents do not distribute. Let me say that again. Exponents do not distribute. Now, I want you to write that down. Exponents do not distribute. I emphasize that because every year people distribute exponents. And it's a tragedy because it leads to wrong answers. And so what's going on here is you're saying x plus 8 squared. Well, if you know x squared is x times x plus 8 squared is simply x plus 8 times x plus 8, and then plus 35. So, with that being said, we're going to now just work this out. I'm going to distribute the negative 2, so negative 2x minus 16 times x plus 8 and then plus 35. Now we will multiply the binomials together. So bring it down, y equals, and we'll distribute the negative 2x to both terms, leaving us with negative 2x squared minus 16x. And now we'll distribute the minus or negative 16 to both terms here. Minus 16x. And that should be negative 128 plus 35. Okay, so now we'll just combine our like terms, and we'll have y equals negative 2x squared minus 32x minus 93. And that is in standard form. Ax squared plus bx plus c. And we box that in, more or less. So that's graphing quadratics in both vertex and intercept forms, and then converting both of those forms into standard form. And that's it. I'll see you on the flip side.